we wanted to do here was start a little bit, give you an idea of what Quarkus is first, kind of what where it came from, what its goal is, and what it's trying to do, as well as then get you into how we're actually applying it to the serverless environment. So that being said, let's start here. So the Quarkus is a supersonic subatomic Java, and if you ever get asked the question or you're wondering where did the Quarkus project name come from, here it is. So quark is an elementary particle. It actually is what makes up protons and neutrons. And us is the hardest thing in computer science to tackle. So it's kind of a tongue-in-cheek on its small size footprint, as well as a nod to developers. So let's take a step back and let's look a little bit at the history that gives us a little bit of context to understand what problems Quarkus solves and why it's quickly becoming so popular among developers worldwide. So Java is turning 25 years old this year in 2020, and Java and the Java platform have been very successful over the years, and there's upwards of 10 million Java developers worldwide. And so organizations run their businesses successfully using Java. Many organizations do. And really Java has become the enterprise workhorse for developers and for organizations. The thing to remember is that Java was created in a time when cloud and containers and Kubernetes and those types of things did not exist. So typically during the last 20, 25 years, long startup times were dependent upon what the application actually did. And it really was not a major concern for applications because they were typically long-lived, meaning they were up for weeks, months, and sometimes years. And so, speed to startup was not that big of a deal, and really memory consumption was not that big of a concern as well because memory was purchased ahead of time. It was on bare metal servers and basically allocated in a heap size. But as the service-oriented architectures and those monoliths were the development paradigms during that time. So Java really worked well and continues to work well when you're thinking about those architectures. But as new development approaches started to seep into the landscape, like microservices and cloud-native applications, when those were introduced, Java continued to remain relevant, even in that market. So many of the microservices frameworks, such as Spring Boot or MicroProfile, they really were still based upon Java and the JVM. Now, with these microservices, being applied to highly distributed architectures, obviously, things like Kubernetes, boot time started to become more important because these applications, such as microservices, they had shorter life cycles. They were being updated quicker, and we needed, more importance was put on start time. And then memory obviously became even more of a top of mind for developers as things like Spring Boot and those applications tended to take up a lot of memory. So the challenge of running Java in the cloud and containers with Kubernetes is that it did consume a lot of memory. It was traditionally slower to start up, and so thus organizations and developers were looking for alternatives like Node.js and Go. And so the reason why the existing Java developers shied away is that it wasn't high performance. So here enters Quarkus. So Quarkus now is a way to utilize those Java skills in this new world of containers and microservices and serverless and those types of things. So Quarkus gives existing Java developers the ability to leverage their skills for a new architecture. So one of the important things about the upstream project for Quarkus is that it really was a collection of experts from different popular open source projects that are traditionally used in cloud-native architectures. And what was done was we asked those individuals to help to optimize their frameworks and port it to Quarkus. So the project was actually started in 2019, and so it is just over a year old, and there are actually a lot of production users of Quarkus in production. So it's quickly being adopted by developers. So Let's talk a little bit about the business value that Quarkus brings. Any lasting technology solves a business problem. And so when we think about Quarkus, we think about three things. One is cost savings. So this has a lot to do with the efficiency gains from the low memory and the fast startup time from a cloud perspective. So when we talk about those two types of things, it's really talking about saving money on your cloud infrastructure. But also from a cost savings perspective, we're thinking about low learning curve. So this idea of leveraging existing Java skills and expertise that developers and organizations have and applying it. So then there's less training and less costly maybe hiring of new resources with different skills. As well as Quarkus is a great fit for serverless architectures because it has a low footprint and starts up so quickly. This obviously allows you to take functions or capabilities that aren't often used and applying it to the, running it when it needs to, so saving money. Also, faster time to market. So we talked about this low learning curve as well as making developers efficient. And we're going to talk a little bit later about developer joy and what Quarkus brings to developers. As well as there's a massive extension ecosystem. So Quarkus is built on this concept of extension libraries. So it allows service providers and software vendors to modernize and customize their libraries to Quarkus. So it basically allows developers to focus on their business logic, not on connecting to different services and utilizing technologies. And lastly, remain competitive. So Quarkus is a Kubernetes native Java stack, so it leverages obviously the scalability of Kubernetes in this modern world of cloud native development. And so this allows organizations and developers to respond and react to business and customer needs quicker. Those are really the three main business values. So let's kind of move on and talk a little bit more about technical differentiators for Quarkus. And when we think about that, we think of a couple of things. First, Quarkus has the ability, compared to a traditional Java stack, to use 1/10 of the RAM usage, as well as being 300 times faster in startup. Now, a little caveat here is that, we'll talk a little bit later, Quarkus has the ability to run on a JVM, but also has the ability to be compiled down to native code. When we're looking at, really compelling numbers, we see extremely compelling numbers from a JVM, and even more compelling when we talk about native compilation, and that's what you're seeing here. So from a differentiator's perspective, Quarkus is geared towards containers, so it's Kubernetes native Java. So it tailors your app to both OpenJDK hotspot as well as GraalVM, so that's the JVM versus the native compilation. We talked about this already, so fast boot times and low memory footprint, and once again, a great serverless fit. Developer joy. We can't stress enough the importance of the developer joy and what Quarkus brings. One of the founding principles of this project was to bring joy back to Java developers. So what does that mean? There's things like live coding and unified configurations, and we'll dig into that a little bit more. Another differentiator is that it unifies both the imperative and the reactive programming paradigms. So in this modern age, you're starting to see a lot more event-driven and reactive applications, and that's a completely different shift for a lot of traditional developers from the imperative model. What Quarkus does is it brings both of those capabilities into one framework. So it allows you as a developer to choose either which paradigm you like or whatever paradigm is required of your application. And more importantly, it allows you to utilize both of those in a single application in the case of microservices. It utilizes a built-in event bus to accomplish this. And lastly is this best-of-breed libraries and standards. Once again, Quarkus is built on an extension ecosystem idea where there's over 90+ extensions right now, and this allows developers to focus on their business logic. So if we dig into these differentiators a little bit, I just want to talk and show you a few more things about that. What we're looking at here is a typical RESTful CRUD application. And you'll notice as we're moving right to left, if you have a traditional Java or cloud native stack, this would be things like Spring Boot or EAP. This is the memory consumption of this application. So if you look at Quarkus, compiled into JVM, you see significant improvement. So from 218 megabits of memory down to 130. And then if you were to go an additional level and compile down to native, so Quarkus plus GraalVM, you see additional memory savings and down to the 35 megabits. So pretty compelling there. What you're seeing below is time to first response. So this is actually compiling an application and being able to handle incoming transactions. Same thing, top to bottom, or bottom to top, excuse me. You see a traditional native stack would be roughly 10 seconds. Quarkus with the JVM is about 2.5, and then Quarkus with compiled into native mode is down to 5 milliseconds. So once again, just really compelling and interesting metrics from a performance perspective. Developer joy, this is perhaps the most exciting and one of the nice features of Quarkus is that there are a lot of different features and functions that geared towards developers. So it's based upon the standards. So this is what we hear a lot is this is the Java it's familiar and new at the same time. So they're familiar with the APIs that they've already been using, but it's applying it to new technologies and architectures. There's a unified configuration. There's live coding. So if you make a change in your code and you refresh your browser, those changes are immediately visible. And Daniel will show you some of that. Pretty exciting. Once again, to this idea of streamlining code for 80% common usages, this is that same logic of leveraging the extension ecosystem to gain efficiencies there. A little bit more about this unifies imperative and reactive. It combines both reactive and imperative development into the same application. And once again, whether it's your preference or what your application requires or needs, or a combination of both, you have the ability to do that. It utilizes both it injects an event bus or the Vertex context, so if you're looking for some details. It actually uses Vertex and netting under the hood. So once again, it's key for reactive systems based on event-driven applications. So it's a great fit if you're looking for to develop some reactive applications. Frameworks and standards that we've been talking about with this extension. So things you may already be familiar with, such as Hibernate or Kubernetes, or if you're doing any sort of metrics and monitoring with Prometheus. So there are, like I said, over 90 plus extensions at this point, and there are more being added every week. So if you're interested in seeing the latest and greatest, check out Quarkus.io. All right, with that being said, that's kind of the background into Quarkus itself. And Daniel's going to take over and tell you a little bit about serverless and do a demo. Daniel?
Thank you, Jeff. My name is Daniel. I'm working with Jeff at the technical side, a little bit more Quarkus and retail runtimes. So let's really talk about serverless architecture, why we needed to do this, and how the application was evolving and designed and deployed in this era. So you can see there are three different pillars in respect to how our application is developed for many years. So in this era, in a modern application architecture, all the application should be handled by a single service to process your business logic and business requirements. And each microservice application should be and can be running on a single purpose, as well as the independent runtime like a Spring Boot, Node.js. And we're going to show Quarkus today about microservice as well. So, and this application linked to the single function to handle event-driven or message-driven architecture. So this is the reason why the modern microservice application to evolve serverless architecture. So I'm going to just highlight quickly what serverless is. I'm pretty sure many people already know what serverless is, but the one thing I want to highlight once again is the serverless is just service and running on multiple cloud, and can be running on hybrid cloud and Kubernetes cluster, and even different virtual machine. And behind the scene, there are many infrastructure like containers and networking and storage and virtual machine. But developers don't want to care about that. That is the you should care about what serverless is. So how to market and software vendors to catch up these needs from the developer and IT operation team to handle serverless workloads. So back in 2014, Amazon released a Lambda service, and the Lambda only served the one single function and running on Java application with the HTTP protocol, but there are some limitations to execute running on your serverless application, aka file mini. So at a time, people understand that, oh, the serverless application does not fit in a stateful application. So that's why the serverless architecture evolved to with the container technology. We can call that 1.5 version. So now serverless with the Linux container technology and running on Kubernetes cluster. So you can deploy any application runtime like a Go, Python, JavaScript, and Java, no limitation of the language platform and framework, as well as you can handle traditional microservices application as a function as a service on top of that. So, but now, what is the missing piece at this moment, 2020? So we have serverless with the container on Kubernetes, and you can develop any language platform to run serverless application on Kubernetes cluster. But one missing part is integration area. So which means it's really hard to integrate legacy system for event-driven architecture or message-driven application programming within your serverless. So now one of the common use case to implement serverless with the event-driven architecture. So we can say to the old version of the serverless architecture definitely needed to handle event-driven and enterprise integration and stable application with the serverless functionality. So why we need to serverless, and specifically developer and even IT ops team. So the developer standpoint, they just need to run application anytime, anywhere, which means could be multiple Kubernetes cluster, could be public cloud or on-prem, on-prem Kubernetes cluster. They don't care about that. Just deploy your application as run serverless anytime, anywhere. This is the cloud agility, we can call that. And your serverless application can be triggered any event, like from a RESTful API from any other application, or any end user just click on your mobile application. At that time, that event will trigger your serverless application. So people more focus on business result to save your infrastructure layer, you maintain cost. Like you don't need to run application all the time, which means you can save your money from maintaining your hardware and even software license. And the application should be scalable automatically according to demand, for specifically the seasonality. So this four thing is the main features, benefit, and capability of serverless application. But one thing for more very, very important for developers' perspective, they just want to deploy the application, but don't worry about the infrastructure layer, and also saving costs from infrastructure layer as well. So let's a little bit drill down and Java perspective of serverless story. So this is the historical enterprise Java stack. Maybe you are so familiar with that. You have some experience of Java application development in the last couple of years. So monolithic application architecture, it was really awesome, but there are two big concerns to maintain your monolithic application. You got to spend a lot of time to change the single piece of the application feature. You need to do everything once again from testing and migration and regression and all performance testing whenever you change a single piece of the application. So, and also it's a huge, big memory footprint and takes a lot of time to start up your application. So this is the historical enterprise Java stack. So that's why we made an enterprise Java stack based on monolith, the modern application architecture, aka microservice architecture. So now you have a single application that you can develop in just a couple of days and deploy in production environment in a small memory footprint, like 100 megabyte, and you just need a couple of seconds to start up your application. But one point you need to be aware that the center parts, the architecture, the Java is still have dynamic application framework. This is the reason why Java was born back in 1990s. So you just need to develop the one Java application, but deploy any application server around the world using the www architecture. That was really awesome because Java just made the bytecode, the immediate application, but it's not complete application binary. But you can get all application server like using JVM technology. Interpret your bytecode to run everywhere. So this is a dynamic capability from Java technology, but we changed the runtime infrastructure from JVM or just single application to Kubernetes cluster, which means that you just deploy, you just build just one time, but you need to deploy 1,000 times with the same application. So that's why this dynamic capability from Java not going to be a good benefit in this serverless architecture. So that's why the people saying Java does not fit in serverless. So people more move to Node.js and Go, even Python to develop the serverless application, specifically running on Kubernetes cluster. Now you can see here the traditional cloud-native Java stack means Spring Boot, JBoss EAP, and WebSphere, all traditional Java application, but lightweight architecture, but still the low memory, the low the resource density. You can see here, you can have the same Kubernetes to work on it, but you can just run a full application with the traditional cloud-native Java stack, like a full pod, but you could have a double time and twice Node.js application pod, but maybe 3 times of the Go application. This is the truth of Java with the container technology. So how Quarkus and Knative change this truth? So you can see now that with the Quarkus running on JVM and running on native compilation on GraphVM, Jeff already mentioned what difference between JVM and GraphVM stuff. But now you can see with the Quarkus on JVM is a pretty much a better high resource density than traditional Java application stack, and almost same Node.js. And you could even when you develop and deploy Quarkus application on the native Java stack, and you have almost same Go application as a part of the resource density perspective. So now the Quarkus enable the Java developer to optimize your application stack to run Kubernetes cluster. So now you can see the single application, but you can change that, the memory footprint as well as the startup time. I'm going to show you a quick demo in a minute, but just one thing, you can still have 2 options. You can develop, deploy the Java application running on JVM as well as the GraalVM for more high performance. So let's go to quick demo. So one of the good, easy way to get started the Quarkus developed application, you can go to quark.quarkus.io and you can download the whatever you need, the dependency capability. So you can change the group name and change the artifact, and you can select a Maven or Grad as a build tool. And now you can add the extension. We can code that from Quarkus, but you can easily understand the extension equals capability. So you can add REST API, or you can add data transaction, etc. Once you're done, you can download the G file and just extract the file, and you can get started to develop from scratch. So in order to save the time, I already downloaded one of the extension and the Maven project. You can see here. So go to PalmXML, you can see the Quarkus version. So we actually reached 1.3.0 final yesterday, but this is a pre-released one. And you can see here dependency automatically inject your PalmXML. This is a simple application to exploit the RESTful API-hello. The one of the easy to start the application Quarkus dev colon. The development mode you can see here. The debugger, the port is activated, and you write version of the Quarkus, and go to the web browser to access the endpoint. So here is a welcome page of the Quarkus, and go to API endpoint, and you can see here. I'm going to zoom in a little bit more to see easy. The hello, the endpoint. So let's make change code as a developer daily work. So welcome Quarkus with the serverless. And I'm going to save the file and reload the web browser. And now you can see the result is changed automatically. It's kind of magic. In the behind the scene, Quarkus just need 1.3 seconds to repackage, redeploy, and run this application. This is the meaning of live coding. So now I'm going to package this application before deploy the Kubernetes cluster. So it's the same command line, Maven plugin, and now you just need the 5 seconds to package your application. So using Java command line to run this application, to make sure this application works totally, and just run using fetcher. But just I'm going to show you the memory footprint when I run this Java application. Once you run this application, you can see half a second to start up. This is faster than any other Java application still. And you can see product activated. And go to web browser, reload the application. Oh, this application, it works properly. And go back to memory footprint. Now you can see here 188 memory footprint. Just a reminder that I'm going to show you very interesting just a little bit later. And now I'm going to package it once again as the executable file using native compilation. The native profile already put in your PalmXML. This is going to be takes a couple of minutes because the Quarkus package all dependency and library at build time rather than runtime. This is the secret source how Quarkus make it faster than any other application. It could be. It takes just a milliseconds to start up. I'm going to show you that thing right away. So once you go to target directory, you can see here executable file, just like a Go. You don't need it to JVM any longer. Just run this file. This is a executable. So now you can see just a 15 milliseconds to start up. This is super cool. And go to web browser once again, and just make sure the application works. They're totally working. That's cool. And go to see a memory footprint here. Now you can see just a 6 megabyte. The same application, but totally different, maybe 100 times less than memory footprint. This is the reason why we can call it supersonic subatomic, the Quarkus application. One thing you should know that the native executable file can be running on where you build this application. In this case, I'm going to use a Mac browser, the Mac OS, so you can see the Mac OS 64-bit. So in order to packaging again with the executable file running on Linux container operating system. You can just setting on property file in application profile here. Now you can see here the Linux executable file format. So now we're going to deploy this application Kubernetes cluster. I'm going to use OpenShift for the 4.3 cluster based on Kubernetes. And one of the good beauty of the OpenShift cluster, you can use the dev console. Just go to create a new project, serverless-demo, and you can go to import container image. I already pushed this image on my external registry like a Docker Hub or Crate.io. And one thing you need to do, just click on Knative service. And now OpenShift will deploy this application as serverless automatically. Now you can see here, and you can go to click on open URL, and you can see the same result. So welcome Quarkus with the serverless. So and this application will be scaled down to 0 automatically in 30 seconds. This is the default configuration of a serverless on OpenShift container platform. You can actually edit that thing like a 1 minute or 5 minutes along with your application the capability. So now I'm going to reload this application, just reload, and automatically this application goes up, automatically scale up. This is the exact feature and the capability of serverless. Just one thing, I want to show one more thing. Go to pod, and you can see the log, and here it's a 50 seconds to start off this application. So there are many choices to develop a Java application and deploy serverless. But the Quarkus make it faster, make it easier, and make it better. So I want to show you one more thing. So you can deploy this application to Azure function. So one thing you just see, I want to add the dependency and go to make sure to log in Azure Cloud. And here is the Azure function Maven plugin already put in the Quarkus as extension. And using the same Maven plugin, but dash the Azure function parameter. And this is automatically package the application and deploy Azure function. Now you can see it's just get started, create the new Azure function. And let's go to Azure and go to function add menu. And now you can see Quarkus dash add function. It's already deployed. The beauty of the Quarkus, you can develop one application but deploy multiple serverless platform like an on-prem Kubernetes cluster and go to Azure function and Amazon Lambda. You don't need to change any code on your application. Just use multiple Quarkus extension and deploy the hybrid cloud and hybrid serverless platform. So this is the benefit of the Quarkus and how to develop Quarkus application and deploy serverless